ahead with a very important question. Now, this particular question involves a lot of geometry. Now, what's the reason for this? Observe the diagram. In this question, you can observe that you have a very big rectangle, isn't it? The standard shapes that are given to us to get this composite shape is a very big rectangle first of all. Then can you see you need to remove a right angle triangle and a semicircle. So if you cut this part from here, then whatever shape is left is your composite shape. Now, the challenge in this question is that your semicircle is not present in the standard position. Now, when I say standard position, there are two positions, students. One is the diameter is horizontal and the second one is diameter is vertical. Getting or not? So we have seen questions when the semicircle was placed in such a way that the diameter is sometimes kept horizontal and sometimes the diameter is kept vertical. Now, when the diameter is horizontal or vertical, at that time finding the centroid of the semicircle is very easy. But in this particular question, and students, I will take one more question where the semicircle will be in an inclined nature. That means the diameter of the semicircle is going to be inclined. So how to tackle such kind of questions is what we need to see in this particular question. So it is going to be a challenging question. You will have a lot of geometry over here. So you need to pay proper attention for solving this problem. So now, before I proceed with the semicircle, there are two standard shapes which are quite easy. One of them is a rectangle and the other one is a triangle. So I need to take a look at the dimensions. So very quickly, let's begin with the solution of this question. So if I take the very first standard shape, which is a rectangle. So what are the dimensions? The width is given to us as 25 centimeters and the depth is given to us as 20 centimeters. So it is very easy to find the centroid of the rectangle. So let's begin with the first standard shape. So I have the very first standard shape as a rectangle. So let's draw the diagram. So we have x-axis, we have y-axis. What are the dimensions given? It is 25 centimeter and 20 centimeter, isn't it? So let's draw a rectangle whose dimensions are 25 by 20, isn't it? So this is the rectangle. The dimensions given to us are 25 centimeters and 20 centimeters. Getting? Now we know that the rectangle is a symmetric shape, isn't it? So let's draw the lines of symmetry. So there are two lines of symmetry over here. These are the lines of symmetry and they both intersect at the centroid, say G1. The distance of the centroid from the y-axis is x1 bar and the distance from the x-axis is y1 bar. So let's very quickly write area x1 bar and y1 bar. So what is the area here, students? A1 is going to be B into D, isn't it? So the width multiplies with the depth. So the width is 25 centimeters and the depth is 20 centimeters. So that's 25 into 2, which is 50. So that becomes 500 centimeters square. So that's A1. Let's get x1 bar now. Students, x1 bar is going to be what? It is going to be half of this 25 centimeter, which is B upon 2, I can say. So that's 25 upon 2. If you want, you can write the simplification. It is going to be 12.5 centimeters, isn't it? So that's x1 bar. Let's very quickly get y1 bar also. So it is going to be, so the depth D upon 2. So that's D upon 2, which is 20 upon 2, or I can say it is 10 centimeters. So I've got A1, x1 bar and y1 bar. So that was my first standard shape, which was the very big rectangle. From this rectangle, you are going to remove the triangle and the semicircle. So the areas are going to be negative, but this will be taken care at the end. At this moment, we'll write the areas positive. So the second standard shape is going to be a right angle triangle. Now, do you know the dimensions of the right angle triangle? Look at this. I'm going to name this point as, say, E. Let's name this point as E. So I know the length of BE, which is one of the perpendicular sides of the right angle triangle. So BE has length 10 centimeter. What about the other perpendicular side, which is CE? So CE, the length is not known to me, isn't it? So my first job is to find this particular length. So let's work out with the length. So I need to do some geometry over here. Observe carefully the angle made by BC, which is the hypotenuse. with the horizontal line is 30 degrees, and you can definitely say that this angle will also become then 30 degrees, isn't it? So we have this right angle triangle over here. This is BEC. This right angle triangle has one of the angle as 30 degrees. This angle is definitely 90, and you can now very surely say that the remaining angle is going to be 60 degrees. So this right angle triangle BEC is also a 30, 60, 90 triangle. So I need the length of CE as well as students observe carefully who is BC. BC is the hypotenuse of the right angle triangle as well as it is the diameter of the semicircle. So BC is a common side to the right angle triangle and the semicircle. It is a diameter of the semicircle and it is a hypotenuse of the right angle triangle. So I can say here this BC is what? Is the hypotenuse of triangle BEC and it is the diameter of the semicircle, isn't it? So I should be getting BC also. So I need to find BC as well as EC. So let's work out in the right angle triangle BEC, which is a 30, 60, 90 triangle. So I'm going to write my geometrical part over here. So in right angled triangle BEC, which is a 30, 60, 90 triangle, isn't it? It's a 30, 60, 90 triangle. So I know BE is 10 centimeter. It is a side opposite to 30 degrees. So it must be half of the hypotenuse, isn't it? So sides opposite to 30 degrees are half of the hypotenuse, and side which is opposite to 60 degrees is going to be √3 upon 2 times the hypotenuse. So I know the length of the side which is opposite to 30 degrees. So here I can say BE is going to be half of BC, isn't it? Half of BC. So I will say here side opposite to 30 degrees. So I know what is the length of BE, isn't it? The length of BE is 10 centimeters. So it is very easy to find the length of BC now. So therefore BC becomes 2 times of BE, which is 2 into 10, or I say 20 centimeters. So I've got the length of BC. Let's very quickly get the length of CE also. So CE is a side opposite to 60 degrees. So it must be √3 upon 2 times the hypotenuse. So I will write here CE is √3 upon 2 times of BC. The reason is side opposite to 60 degrees. So let's very quickly get the length of CE. So therefore students, I can say CE becomes √3 upon 2 times of the hypotenuse, which is 20. So my answer comes 10 √3 centimeters. So I've got the values of CE as well as BC. So now I know that the diameter is of what length. So therefore diameter has come 20 centimeter. And what is the length of CE that I've got? The length of CE has come 10 √3 centimeters. So this length CE has come 10 √3 centimeters. Now let's draw the diagram. You should always draw the diagram with respect to the original x and the y axis. Draw it at the exact same position wherever you find in the original diagram. So you can see that there is a very big rectangle over here, and this particular right angle triangle is in the extreme right of the rectangle. So here I'm going to draw the exact diagram over here. So my second standard shape is a right angled triangle, isn't it? It is a right angled triangle. So students, let's draw the diagram first of all. So we have this x-axis and the y-axis, and then I have the rectangle. What is the dimension of the rectangle given to us? The rectangle has dimension. This dimension here is 25 centimeters. This is 25 centimeters, and this dimension here, the depth is 20 centimeter, isn't it? So this is 25, this is 20 centimeters. So where is a rectangle, where is the right angle triangle placed with respect to the rectangle? So you can observe that it has this midpoint which is B, then there is this point which is E, and then we have this point C. So let's join this B, E and C. This is where your right angled triangle is present, isn't it? What is the length? Let's very quickly write the length. So this length is 10 centimeters, isn't it? This is 10 centimeters. This is also 10 centimeters. And the length of CE is how much? It is given to us 10 root 3. 10 root 3 centimeters. Now, we know how to locate the centroid of a right angle triangle. It is always at 1/3 distances from the perpendicular sides. So, CE and BE are the perpendicular sides. So, you come to CE, come to 1/3 distance and draw a vertical line, isn't it? So, this is the vertical line which is parallel to BE, the other perpendicular side. It is at a 1/3 distance from BE, isn't it? Similarly, you take BE, isn't it? This is the perpendicular side. So you take 1/3 distance over here, isn't it? And draw a line which is parallel to CE. Both of them intersect at a point which is the centroid. So I'm going to call this as G2. Further, let's identify the distances also very quickly. So this distance is going to be, if I call this 10 centimeter as say B, I'm going to call this as B. The bigger length I'm going to call it as H, let us say. So this is H. So these distances are going to be, the smaller distance is going to be B upon 3, isn't it? Whereas this distance is going to be H upon 3. So this is H upon 3. Now students, I've got these distances, this H upon 3 and B upon 3. Observe carefully the diagram. Can you see that this H by 3, B by 3, are they the X bar and Y bar for the right angle triangle? The answer is no. It is not X bar and Y bar for the right angle triangle. You should always tell the distance of the centroid from the original Y and the X axis. The distance of this centroid from the Y axis, that will become your X bar. The distance of the centroid from the X axis, that will become your Y bar. So you should be very careful to tell what is X bar and what is Y bar. It is not always H by 3 and B by 3. You need to understand where the axes are given to us and how the triangle or how the standard shape is positioned. Accordingly, you will get the values of X bar and Y bar. Now, H by 3 and B by 3 are the standard values, the standard formula of a centroid for a right angle triangle, but it not be always X bar and Y bar. So you need to take care of that particular thing. I have seen a lot of students doing this particular silly mistakes while writing X bar and Y bar. So H by 3, B by 3, that comes from the formula, but here it is not valid because the centroid is here. This is the Y axis. So I need to find the distance of the centroid from the Y axis. That is going to become X bar. So students, look at this. So, if I draw a perpendicular from the centroid G2, isn't it? This is the centroid G2. This is a perpendicular on the y-axis. This perpendicular is going to be X2 bar, and the perpendicular from G2 on the x-axis, this is going to be y2 bar. So clearly you can understand that x2 bar is not h by 3, y2 bar is not b by 3, isn't it? But now I want to get this x2 bar. So first of all, I'm going to write the area, students. Let's write very quickly the area. So what is the area going to become? It is half into the product of perpendicular sides. So I know the perpendicular sides are what? 10 root 3 and 10. So I write here 1 upon 2, 10 root 3 into 10. So this gives me what answer? So 2 and this 10 cancels. You get 5 here. 5 into 10, that's 50. So you get 50 root 3 centimeters square. So that's the value of area of the right angle triangle. Let's quickly find the value of x2 bar. Now be very careful while you tell me x2 bar. So this x2 bar is actually the total length. Observe carefully. The total length, which is 25. From this, if you subtract this h by 3, you will be getting the value of x2 bar. So this is 25 centimeter minus h upon 3. That's my value for x2 bar. So let's very quickly write the value of x2 bar. It is going to be 25 centimeters. So that's 25 minus h by 3. What was the value of h? It was 10 root 3. So this becomes 25 minus 10 root 3 upon 3. I'm definitely going to simplify this particular value. We have to simplify such kind of calculation. So 25 minus 10 root 3 upon 3, whatever the answer comes, I will be writing that particular answer over here. Likewise, now students, can you tell me what could be the value of y2 bar? Think for a moment and let me know what could be y2 bar. So students, y2 bar is going to be this 20 centimeter minus b upon 3, isn't it? So let's write the value of y2 bar also. So y2 bar is going to be this entire 20 centimeters minus b upon 3. So that's 20 minus b is 10. So this is 10 upon 3. So I certainly need to get this value also. So if you simplify this, this is 20 into 3, isn't it? So 20 into 3, that becomes 60. 60 minus 10, it is 50. So you can straight away write 50 upon 3 also, or you can do some simplification there. So that's my y2 bar. So this was my second standard shape, the right angle triangle. Now students, you need to be very, very, very attentive from here onwards, because we are going to start with the semicircle. So students, let's now proceed with the semicircle. Don't we know that for a semicircle, the centroid always lies on the line of symmetry, and it is always at a distance of 4r upon 3 pi from the diameter of the semicircle, isn't it? So this one basic rule should always be remembered while writing the centroid for a semicircle. So this is the semicircle that is given to us. It is not in standard position. The diameter is not horizontal. The diameter is not vertical. But I am very sure that the centroid is definitely going to lie on the line of symmetry. So my first job is to identify the line of symmetry, where the line of symmetry is going to come. So students, this is diameter BC, isn't it? So I know that the line of symmetry is definitely going to be passing through the center. So first you identify where you can locate the center. So it is obviously the midpoint of BC. So this is BC, and I take the midpoint of BC as, say, F. So F is the midpoint of BC, which is the center of the semicircle. So line of symmetry is definitely passing through this F, isn't it? And it is perpendicular to BC. So students, this is the line of symmetry that we can make over here. So this is the line of symmetry. Line of symmetry. And where does the centroid lie for the semicircle? It lies on the line of symmetry at a distance of 4r upon 3 pi, isn't it? So from here, from this diameter BC, you come over here, this point where the distance is going to be 4r upon 3 pi. So I'm going to locate the centroid, say somewhere here. This is going to be G3, isn't it? That's my third standard shape. So this is G3, and the distance of FG3, if you observe, this distance of FG3 is going to be how much? This distance is going to be 4r upon 3 pi. So what's the radius? I know that the radius is 10 centimeter, because the diameter has come 20 centimeter, isn't it? The length of BC, students, has come 20 centimeters. This is the diameter of the semicircle. This is BC here, which is the diameter of the semicircle. It has come 20 centimeters. So the radius comes how much? It comes 10 centimeters. So I know radius is 10. So that becomes 4 into 10. That's 40 upon 3 pi. So I know this length FG3 is 40 upon 3 pi. So this is what now you need to understand. This one concept that I'm going to teach you, how to find the values of X bar and Y bar for the centroid over here. Remember students, this 4r upon 3 pi, in no way you can tell it is X bar or Y bar now. It is a clear indication, isn't it? You should always know that the horizontal and the vertical distance of the centroid from the Y axis and the X axis, that becomes our X bar and Y bar. So this is the centroid, this is the Y axis. You need to draw the perpendicular from the centroid on the Y axis. That will give us X bars. Observe here, students, observe here. I am drawing the horizontal line over here. Look at this. From here, I've drawn the horizontal line. Isn't it? It is the perpendicular line. So this particular perpendicular line drawn from the centroid G3 on the y-axis, this line is your X3 bar. Isn't it? So that's X3 bar, students. Likewise, from here, if you draw a perpendicular on the x-axis, this length is going to become y3 bar. So your challenge is to get this x3 bar and y3 bar, and you know the length of fg3, which is 4r upon 3 pi. So from this fg3 you should be getting x3 bar and y3 bar. So a real challenge has been developed over here. Now you need to know your geometry very well, otherwise this question cannot be solved further. So let's begin how to get the answer. Now again, another concept that you need to remember over here, these are some particular points you want to remember. First of all, I have located where the centroid is on the line of symmetry at a distance of 4r upon 3 pi. I know this distance. I am interested in getting the distances x3 bar and y3 bar. The next thing that I'm going to do here is, the second very important point is, from this center F, again you draw perpendiculars on the y-axis and on the x-axis. These perpendiculars will become what? They will become the coordinates of the center of the semicircle, the x-coordinate and the y-coordinate. So students, I am going to draw perpendiculars from F on the y-axis. This is the perpendicular drawn on the y-axis. So let's call this as FM, and there is another perpendicular which is drawn on the x-axis. I'm going to call it as N. So FM and Fn are the x and the y coordinates of the center. Getting on the x and the y coordinates of the center. Again, students, observe carefully what other thing I'm doing. Here, let's extend this. Let's extend this perpendiculars a little bit further. Okay, so this is, I'm going to call it as, say, FP and FQ. Getting? I have extended FP and FQ. They are again perpendiculars. They are also perpendiculars drawn from F on the adjacent sides of the rectangle. So this is all the construction part. You need to understand this thing. You need to revise this question on your own also. You need to solve it. Then only you will recall all these things that I'm going to do over here. So this is FP and FQ that I've drawn. My job is to get the value of x3 bar and y3 bar. Now the most important part of the solution. Look at this. Now from this G3, students, what I'm going to do is, from this G3, I'm going to draw another perpendicular on this Fn or Qn, you can say. Let us name this point as L, and you should focus on this small triangle FLG3. Look at this triangle FLG3. Your attention must be on this triangle FLG3. If you get the value of LG3, students, LG3, get the value of LG3, get the value of FP, get the value of x3 bar. So x3 bar plus LG3 plus FP, is it going to become 25? Isn't it? It is going to become 25. Now, there is a possibility to get LG3. There is a possibility to get FP. I can get these values. So, LG3 is known. FP is known. This is 25. So, is it now possible to get me the value of x3 bar? Isn't it? It becomes easy to get the value of x3 bar. Likewise, students, look at this. This is y3 bar. This is y3 bar. Then look at this. This is FL, isn't it? And then students somehow try to get FQ. So FQ plus FL plus this y3 bar. So this y3 bar plus FL plus FP will become 20 centimeter. There is a possibility to find the value of FL. You can get FQ, then you can easily get the value of y3 bar. So look at the construction very properly. So what you can do here is, there is now no need of this LN. If you want, you can remove this particular line from here, isn't it? This line is not needed. So I'm going to remove it. It's an additional construction. So let's remove this from here. Getting or not, students? It is not needed. Initially, we were not aware what things can be utilized and what things cannot be. So this is not needed. So I have removed it. So now, students, my attention will be on this triangle FLG3. Now observe carefully. If I proceed further like this, LG3, and I proceed with FB also ahead. Observe LG3 and FB. So LG3 and FB are extended in such a way that they both intersect at some place. They are both intersecting at some place. So now tell me, you know that this bigger angle is obviously right angle, isn't it? It is 90 degrees. This angle is 30, so this angle also becomes 30. Look at them, they are corresponding angles. So this is 30, this also 30. So obviously this angle becomes how much? Students, this angle is going to become 60 degrees, isn't it? So you can see that this angle is 60. This is 90. So this small angle becomes 30 degrees. So this FLG3 is not just a right angle triangle. It is a 30, 60, 90 triangle. So I'm going to draw this triangle. I'm going to enlarge the diagram over here. So for the semicircle, I'm going to focus my attention on this triangle first of all. So let's draw a right angle triangle, and it is not just a right angle triangle, it is a 30, 60, 90 triangle. Then tell me the vertices. It is G3, L and F. It is G3, then there is L, and then there is F. What is FG3? Students, FG3, if you recall, it is 4r upon 3 pi. This is 4r upon 3 pi. You know that the radius is 10, so it becomes 40 upon 3 pi. This bigger angle is 60 degrees. This is 90 degrees. This is 30 degrees. So I can make use of the 30, 60, 90 concept, and I'm going to get the values of LG3 and FL. So what is LG3, students? LG3 is the side opposite to 30 degrees. So it must be half of the hypotenuse, isn't it? It is half of the hypotenuse, which is FG3. So let's write the reason: side opposite to 30 degrees. So I get here 1 upon 2 into, what's the length? It is 40 upon 3 pi. So 1 upon 2 into 40 upon 3 pi. So you get 2 and 40 cancels. That becomes 20 upon 3 pi centimeters. So that's the value of LG3. So I've got this small value LG3. Now my job is to get this length of FL also. So let's get FL. So I know that FL is the side which is opposite to 60 degrees. FL is opposite to 60 degrees. So it must be root 3 upon 2 times the hypotenuse. So root 3 upon 2 times the hypotenuse, which is FG3. So I get root 3 upon 2 times of, who is the hypotenuse? It is 40 upon 3 pi. The length is 40 upon 3 pi. So 40 upon 3 pi. So here what happens? Here 2 and 40 cancels, you get 20. Root 3 and root 3 cancels, you get root 3 in the denominator. So that's 20 upon root 3 pi centimeters. Better write the reason also. This is side opposite to 60 degrees. So now I have got the length of FL also. The length of FL also. Now students, I want to get the length of FQ and FP. Now let's focus our attention on this bigger triangle BEC, the right angle triangle BE and C. So I want you to pay attention to this triangle BE and C. So our attention now must be on the triangle BEC. Now students, for the triangle BEC, who is this point F for side BC? F is the midpoint, isn't it? So for triangle BEC, F is the midpoint. So if I draw this triangle over here, so this is the triangle that we have, isn't it? Then the name is B, over here B, then there is E, there is C, then you have this F, the midpoint of BC, isn't it? It is the midpoint of BC. Now, do you recall something called as the midpoint theorem? Students, what is the midpoint theorem? Midpoint theorem states that the side, or I can say the segment joining the midpoints of any two sides is parallel to the third side, and it is always half of it. Haven't you heard of this particular theorem, the midpoint theorem? The line segment which joins the midpoints of any two sides, this line segment is parallel to the third side of the triangle and is also half of that third side. So look at this point F. isn't it the midpoint? It is a midpoint of BC. So from this F, I have drawn a line perpendicular on side EC. So it is definitely parallel to BE. So this is named as FQ. So this FQ is parallel to what? It is parallel to BE. So shouldn't FQ be the half of BE by the midpoint theorem? So I can say FQ is going to be half of BE. So what is the length of BE that you know? It is 10 centimeters. So this is half of 10 centimeter, that comes 5 centimeters. So students, I've got FQ. How much? It has come 5 centimeters. Likewise, there is another length that I've drawn, that is FP. So now focus on this FP. Again, observe carefully. Isn't FP the perpendicular which is drawn? So it is also going to be parallel to CE. So F is the midpoint, FP is parallel to CE, then P becomes the midpoint of BE, isn't it? So FP should be again half of CE, again by the midpoint theorem. So I can write here FP is going to be half of CE. So 1 upon 2, and CE, the length is 10 root 3. So it comes out to be 5 root 3 centimeters, isn't it? So the length of FP has come 5 root 3 centimeters. The length of FQ has come 5 centimeters. So now, students, both these things have been obtained by using what concept? I have made use of the midpoint theorem. So let's write it over here. The midpoint theorem, isn't it? So now I have the length of this FQ, FP, LG3, FL. So now I'm in a position to get X3 bar and Y3 bar, isn't it, students? So now I'm going to get the value of X3 bar and Y3 bar. So now let's draw the last standard shape, which is the semicircle. So students, I will draw the last standard shape, the third one. It is the semicircle. Now there is no need to draw the diagram one more time. It is already present in this particular thing, isn't it? So you just now need to tell what is X3 bar and Y3 bar. So everything is present in the diagram there itself. So there is no need to redraw this particular thing. Okay, so I'm not going to draw the diagram entirely over here because I already have all the contents present in the diagram. So I just now need to get A3, X3 bar and Y3 bar. So tell me, for the semicircle, what is the area going to be? So we know that the semicircle area is pi r square upon 2. So I write here pi r square upon 2. What's the radius that you have, students? Radius is how much? Radius is 10 for the semicircle. So it is pi into 10 square upon 2. So 10 square is 100. Divided by 2, you get 50 pi centimeter square. So that's the area. I've got the area. Then I want to get X3 bar. So this X3 bar plus LG3 plus FP is going to be 25 centimeters. So let's write all these things first of all. So by geometry, I can say of the diagram, you can definitely say that X3 bar, isn't it? X3 bar from the diagram plus that LG3 plus LG3, and then this LG3 plus FP plus FP. This is going to be how much? It is going to be 25 centimeters. So can you get the value of X3 bar from here? Let's get the value of X3 bar, students. So therefore, I get X3 bar is equal to 25 minus, what is the value of LG3? It is 20 upon 3 pi. So we need to do these calculations. We're going to do all the calculations simultaneously at one time itself. And then minus of FP, students, minus of FP. So how much the value of FP has come? It has come 5 root 3. 5 root 3. So I'm going to get the value of X3 bar over here in a short while from now. Okay, I'm going to do that calculation. Let's do it a little later. Now let's get the other value of Y3 bar. So again, you go to the diagram, observe carefully the diagram. What do we have? In the diagram, we have this Y3 bar plus FL plus FQ. This is going to become 20 centimeter. So I write here Y3 bar, isn't it? Y3 bar plus FL and plus FL plus FQ This is going to be 20 centimeters. So from here, I'm going to get the value of y3 bar. So y3 bar is going to be what? It is going to be 25 minus FL and minus FQ. So 20 minus, what is FL that you have got? FL is 20 upon root 3 pi. So I write here 20 minus 20 upon root 3 pi minus of FQ. What about FQ, students? FQ is how much? It is 5 centimeters over here. So minus of 5. So I'm going to get the value of y3 bar also. Let's do the calculations here. Y3 bar. Now, don't I have all the required values to find the centroid of the composite shape? Students, what's the formula for finding the centroid of a composite shape? It is x bar is equal to summation of AI into xi upon summation of AI, and y bar is going to be summation of AI into yi upon summation of AI. So both the formulas are going to require the value of summation of AI. So students, before I do these calculations, let's get summation of AI also, and then we will do all the calculations together. So summation of AI, students, summation of AI in our case is going to be what? I need to keep the rectangle, students. I have to keep the entire rectangle, and from this rectangle I want to subtract the triangle and the semicircle. So the two areas are going to be negative, one area is going to be positive. So I get here summation of AI as what? It is A1 minus A2 minus A3. So A1 minus A2 minus A3, you know what is the value of A1. So let's identify where do we have A1. So this is A1 here, isn't it? It is 500 centimeters square. So that's the value of A1. Then let's identify A2. So where do we have A2? So A2 is this 50 root 3. So this is A2 value, isn't it? So I'm going to just block all these values. This is A2. And then where is the value of A3? It is just 50 pi. Isn't it? The value of A3 is 50 pi. So let's get A1 minus A2 minus A3. So that's 500 minus 50 root 3 minus 50 pi. So students, I'm going to make use of a calculator now over here to find the values of summation of AI and the rest of the calculations as well. Let's first write all the values. So we have the value of A1 as how much? The value of A1 is 500. So I'm going to write here 500. So that's 500 minus, then you have A2. Students, what is A2 value? It is 50 root 3. So I'm going to write here 50 root 3. And then we have A3. So the value of A3 is how much? The value of A3 is 50 pi. So I'm going to do these calculations very quickly. All the calculations which are required. So if you remember, we want to get first of all this x2 bar, isn't it? The x2 bar value. Now look at this. I have this value of x1 bar here, which is 12.5. So I'm going to block this value also. X1 bar. It's a very big question. So I need to pay attention for all my values. I need to take care of all the values very properly. So that's x1 bar, isn't it? Then you have this x2 bar, which is 25 minus 10 root 3 upon 3. I will need to do the calculation over here. So let's take the help of the calculator now. Now I want to do 25 minus 10 root 3 upon 3. Obviously, the root 3 in the numerator and denominator can be cancelled. So one step of the calculation can be saved. So that's 25 minus, you have 10. Then there was root 3 in the numerator and 3 in the denominator. I have cancelled root 3. So in the denominator, I will have just root 3. So my answer comes out to be 19.22649731. So I'm going to write that value as 19.2265. So my value has come here 19.2265. Okay, so that's the value of x2 bar. That's the value of x2 bar, 19.2265. Let's proceed further for x3 bar also. Let's get value of x3 bar. So there is this x3 bar. It is 25 minus 20 upon 3 pi minus 5 root 3. So let's very quickly get that value also. 25 minus, you have 20 upon 3 pi. Then you have minus of 5 root 3. So the value that comes is 14.21768. So I can write the value of x3 bar as 14.2177 centimeters. So that's the value of x3 bar, isn't it? And students, let's mark all the values of y bar also, isn't it? Very quickly get the values of y bar also. So I'm going to get the values of y bar here, students. So what do we have? Y1 bar, it is this 10 centimeters. Y1 bar is 10 centimeters, isn't it? Then what is the value of Y2 bar? It is 50 upon 3. I'm just blocking all the values, so it becomes very easy to find them while doing the calculations. So that's 50 upon 3, that's Y2 bar, and then I need to get Y3 bar. So let's very quickly get the value of Y3 bar also. So Y3 bar is going to be now 20 minus, you have 20 upon root 3 pi, so that's 20 upon, in the denominator you have root 3 pi, then what do we have? Minus of 5. So the answer that has come is 11.32474. So I'm going to write that value also here. So let's write the value of Y3 bar. It is 11.32447. I'm going to write it as 5 centimeters. So that's the value of Y3 bar, students, isn't it? So I've got a value of Y3 bar, and I also want to find summation of AI. So let's get summation of AI. It is going to be 500, isn't it? Then minus of 50 root 3, the second value, and then minus of 50 pi. So minus of 50 pi. You need to do your calculations on your own. Don't just keep on copying the calculations. It is going to be 256.3178. So I'm going to write my answer as 256.3178 is taken as 8 centimeters square. So I've got the values of A1, A2, A3, X1 bar, X2 bar, X3 bar, Y1 bar, Y2 bar, Y3 bar, and I have also the value of summation of AI. So now I am in a position, students, to find the value of X bar and Y bar, isn't it? So first of all, let's write the formula here. So I would write the value of X bar. So let's write in the space that is left. Okay, so I would write X bar here. So X bar is going to be summation of AI into Xi upon summation of AI, isn't it? So I need to do A1 into X1 bar. So that's 500 into 12.5, isn't it? So 500 into 12.5. Then minus, students, isn't it? The second area is negative because you are going to remove the right angle triangle. So minus of 50 root 3 into 19.2265. So minus of 50 root 3 into 19.2265, and minus of there is A3 into X3 bar. So that's 50 pi into 14.2177. So I write 50 pi into 14.2177, that's X3 bar, upon summation of AI. What's that value that we have got? It is 256.318. So obviously I will be doing the calculations for X bar over here. And students, now you know that for Y bar what the formula is going to be. So Y bar is going to be summation of AI into Yi upon summation of AI. So you know what is going to happen over here? A1 into Y1 bar minus A2 into Y2 bar, isn't it? A2 into Y2 bar minus A3 into Y3 bar. So this part I'm going to do directly, students. Now you know how to do the calculation. So let's very quickly find the values of X bar and Y bar. So let's make the help of calculator over here. So X bar is going to be 500 into 12.5 minus 50 root 3 into, the value was for X2 bar 19.2265, then minus of, students, 50 pi multiplies with the value of X3 bar. It is 14.2177. I will get some value. It is 2351.625. This gets divided with summation of AI, which is 256.318. So my answer has come 9.174639. So I can write the value of X bar as 9.1746 centimeters. This is one of the answer, students. That's one of the answer. I've got the value of X bar. Let's get the value of Y bar also. You know what the formula is, isn't it? So I'm going to do the calculations directly. So that's A1 into Y1 bar. So that's 500 into 10, isn't it? So that's A1 into Y1 bar. So 500 into 10. Then minus of A2. So there is A2. There is A2 50 root 3. So minus of 50 root 3. This multiplies with Y2 bar. So what's the value of Y2 bar? It is 50 upon 3. So 50 upon 3, that's the value of Y2 bar, and minus of, again students, A3, which is 50 pi into Y3 bar, which is 11.3245. You'll get some answer. This answer is 1777.776. So this gets divided by summation of AI, which is 256.318. So my answer comes 6.9358. So Y bar has come 6.9358. So students, that's centimeters. That's the value of Y bar. This is going to be the second answer. So students, I've got the values of X bar and Y bar, isn't it? If you observe, this was a really challenging question. Why is it challenging? Here, if you observe that your semicircle is not given in the standard position, it is not horizontal, it is not vertical, it was inclined in nature. So a lot of geometry was involved in this particular question. I'm very sure students, you have understood this entire question very properly. We will take one more question where the semicircle is again going to be inclined, so that our concept builds up very strongly. So students, let's proceed ahead with the next question now.